ओके, यहाँ से स्टार्ट करते हैं।
लेकिन आप ये पूछो और वो आ भी गए ये
थैंक यू।
Welcome back, everybody.
गुड आफ्टरनून सर।
Good afternoon. So, have you got the PDF file that I have sent to you to study?
Yes, sir.
Okay. So now we shall have another lecture session, and the title of this lecture session is Characteristics of an AI Technique, in which we will try to
ফোন করুন না। হ্যাঁ স্যার, ফোন করলে আমি ফোন করেছি,
হ্যাঁ
সে আসতে চাইছে না, তো বলছে আমি আসছি কি করছি, আমি কি করবো স্যার, এখন হাফ ডে করার কথা, তো আমি দেখি কি আর বলি পাঠিয়ে
তোমার এখন কি কাজ?
আমি স্যার যাবো না।
ও তো ওকে ওকে আসতে বলো, এখনই আসতে বলো, আমার কথা বলো, বলো স্যার এখনই ডাকছে তোমাকে।
হ্যালো, হ্যাঁ তো আপনার
So, as I've said earlier that ultimately AI, artificial intelligence techniques, has certain characteristics which enables it to be called as an AI technique. So, in this session, we shall try to understand the basic characteristic of an AI technique. That is, how a computer program, which is supposed to be a program for artificial intelligence, should differ from a conventional, traditional computer program, because ultimately it's a computer program. Okay, so what kind of characteristics, what kind of features make them an AI technique? That is what we are going to consider, and we shall try to understand it with the help of a concrete example. So, let us consider the game of tic-tac-toe, right? Now, all of us in our childhood must have played tic-tac-toe, I am sure, especially during the boring classes towards the rear side of the class. In your notebook, we used to play the game of tic-tac-toe just to kill the boredom. Okay, so in tic-tac-toe we make two parallel lines, two pairs of parallel lines like this, so that this space, this plane, is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 segments, and one player has to play with a cross and another player has to play with a circle. Okay, the purpose is, I want to make, suppose you are playing with cross, so you would like to put 3 crosses in consecutive cells, and these 3 consecutive cells may be in horizontal positions, in vertical positions, or in diagonal positions. As soon as you achieve this, it means that you have won the game. Whoever, suppose that someone, the person who is playing with this circle manages to put 3 circles consecutively vertically in this, it means that he or she has won, and the person who was playing with this cross has lost the game. So generally the person who is playing with cross is given the first chance to put the cross, and then alternatively one person puts a cross, another person puts a circle. So in this way the game proceeds until and unless one of the 2 players wins the game, thereby making the other player lose the game, or the game ends in a draw. That means no one has been able to put 3 consecutive circles or 3 consecutive crosses along a row or column or in a diagonal, but all the places has been occupied by pluses and crosses and circles. So that is no one has won, so that is the end of the game. Suppose that we want to write a computer program to play a game of tic-tac-toe with the user. Okay, so if I am playing with the computer a game of tic-tac-toe, then at the very beginning we will decide whether I will play with a cross or the computer will play with a cross, or the vice versa. And then in consecutive turns there will be 9 turns, 1 to 9. I will put my my symbol, and the computer will also put its symbol. Computer will try to win, I will also try to win. So in this process, either me or the computer will win, or the game will end in a draw. Now we are going to consider 3 different programs to play a game of tic-tac-toe. And these 3 solutions or 3 programs will be according to increasing degree of complexity, use of generalizations, clarity of knowledge embedded, and extensibility of their approach. That is, with increasing degree of AI-ness. So you can understand that by AI technique we mean a technique, a computational technique, where we will be dealing with complexity, we will use generalization, we will use knowledge embedded in the program itself. Not that the knowledge is in my mind and I am writing the program according to my knowledge, rather I will write a program which will exploit knowledge during its execution. The knowledge that is inside me will be transferred to the program. So the program will act according to the knowledge. And extensibility of their approach. Extensibility means how we can generalize, how I can use the same program with little modification to tackle the same problem with another level of complexity. So we are going to consider 3 different solutions with increasing degrees of complexity, use of generalization, clarity of knowledge embedded, and extensibility of their approach to solve the problem of playing a game of tic-tac-toe. And by doing this, we will try to understand the essence or the essential feature of an intelligent technique or AI technique. So here is program number 1, which is rather, what should I say, which is rather straightforward, without much intelligence, but of course very effective. What do? We employ data structure, and we call this data structure to be a board. What is this board? It is a 9-element vector representing the board. Elements of the vector correspond to the board positions. Okay, so in a game of tic-tac-toe there are 9 positions, and these 9 positions are numbered in this way: 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So it is a vector of 9 elements. Here we are showing it in a 2-dimensional. In the actual data structure, it will be a 1-dimensional vector. Now, what will be the content of the individual elements of the vector? It will contain the value of 0 if the corresponding square is blank, 1 if it is cross, and 2 if it is a circle. So, as we have seen that in a game of tic-tac-toe, a board position or a cell can be either blank or may contain a cross or may contain a circle. We will encode a blank with a 0, number 0. We will encode a cross with number 1 and a circle with number 2. So 3 numbers will appear in the vector 0, 1, 2 in the 9 different positions. So how many possible vectors are there? Please note that these are wrong, these have been written in the wrong, not 39, it should be 3 to the power 9 elements. Because in the vector, we have 9 elements and each element have 3 options, 0, 1 or 2. So 3 into 3 into 3 into 3 into 3 into 3, in these 9 3's correspond to 3 to the power 9. So it is a vector that can have 3 to the power 9 number of configurations, depending upon the different situations, both situations, we have these vectors. Okay, now you notice one thing, basically this 9-element vector is a tertiary number. That means a number, an integer expressed in ternary system, tertiary system. That means the digits are either 0 or 1 or 2. And just like any other system of numbering, this can be easily converted into a normal decimal number. Okay? So actually these 3 to the power 9 elements, 3 to the power 9 number of vectors will correspond to numbers from 0 to 3 to the power 9 minus 1. I hope you understand. Now, what is my strategy? The strategy is interpret the board as a ternary number, tertiary number. Express in decimal system. Let the resulting number be x. So during your game, the board position, there will be certain board position. All the cells, all the positions will have either 0, either blank, document is, just a minute, PPT is not visible. Hello? So interpret the board as a ternary number expressed in decimal system. Let the resulting number be x. Okay. Now use this x, that is the number represented by the current board position, as an index into move table. Move table is nothing but a long table. Okay, a table ideally consisting of 3 to the power 9 number of entries. Corresponding to each entry, corresponding to each board position, we define the next move. Next move means the next board position if that move is taken by the corresponding player. So that is also there. So I am keeping all the possible moves as a table. So the strategy is nothing but a table lookup procedure. What is the current position? This is the current position. I look into the table corresponding this current position. This is the next position. So what will make this next position? Okay, this move will make this next position, so I will make this next move. So get the vector stored there, let that vector be V. The vector V is the next move. So the program 1 is nothing but searching a table with the help of an index, and where the data structure is designed in such a way that any board position, any intermediate situation during the game of tic-tac-toe can be converted into a number, and that number is used as an index into a table. That table stores all possible moves. So before you write the program, the programmer has to consider all possible cases and then store those cases inside the program. So the program itself doesn't show any intelligence at all. It doesn't take any decision. It doesn't analyze the present situation. It doesn't apply any kind of knowledge to make a decision. What it simply does is look into the table and copy it into the reality. So the first program is a trivial program with zero or least amount of intelligence embedded in it. Okay, now we go to the second program. Here is program number 2. Program number 2 is a little more sophisticated. Here is program number 2. We use data structure board as in program 1. Just like in program 1, we use a data structure board. And we use a variable turn, which is an integer between 0 and 9, indicating which move it is going to be played. So initially the first move means turn is equal to 1, second move means turn is equal to 2, third move means turn is equal to 3, and so on. Ninth and the final move means turn is equal to 9. Now in this program we use some additional procedures. One procedure is the procedure make 2. What is make 2? Make 2 says if the center square is blank, then return 5. If you look into the board position, this is the configuration of the board, you will see that 5 means board position, 5 means the middle cell. Okay? So here is a little wisdom that is embedded here. It says that if the center square is blank, then return 5. It means that I am looking into the board position and seeing whether the middle board position is blank or not. Else, return any blank non-corner square, that is square number 2 or 4 or 6 or 8. Again have a look into the picture. You see, non-corner, there are 4 non-corner squares. This is square number 2, square number 4, square number 6 and square number 8. There are 4 corner squares, corner number 1, corner number 3, corner number 7 and square number 9. And there is only one middle position, middle square, that is square number 5. Okay. So make two is a procedure which checks whether the middle square is empty or not. If the middle square is empty, then that is returned. If the middle square is already occupied either by a cross or by a circle, then out of the 4 non-corner squares, it returns the one which is currently empty. Another procedure is pos-win P, where P is a player. Okay, pos-win P, P is a player. If player P cannot win on the next move, then return 0. Else, return the square number that constitutes the winning move. So this is a very interesting procedure. Here, just like in normal situations when we ourselves play a game of tic-tac-toe, we try to understand what will be the situation after I make the move. If the situation is such that in the next move itself, the opponent can make a move to win the game, then obviously I will try to block that move, because otherwise I will lose the game. So in order to see whether there is a possibility of my opponent to win the game in the next move, I will have to find which move will make him win the game. If it is not possible for him to win the game in the next move, then the procedure will return 0. So that I will be assured that, okay, at least in the next move, my opponent cannot win. Otherwise, if it is possible for my opponent to win in the next move itself, then which particular move will make him win? That is also I want to know, so that I can make my own preventive move there. That is the purpose. So pos-win is a procedure which goes like this: if player P cannot win on the next move, then return 0, else return the square number that constitutes the winning move. And go n means make a move in square n. Go n means make a move in square n. So with these 3 procedures, 3 subroutines in our stock, we now state the strategy of the program to play a game of chess. It goes like this. You see, for each turn, I have to make a decision. Turn is equal to 1, turn is equal to 2, turn is equal to 3, turn is equal to 4, turn is equal to 5, turn is equal to 6, turn is equal to 7, turn is equal to 8, turn is equal to 9. So let us have a look into the individual instructions of the program. If turn is equal to 1, that is the first turn, go 1. That means the program says that if you are the opener of the game, you put your cross here. there is no, because you are the first one to make a move. And according to our algorithm, that first move must be a cross in the first or upper leftmost corner of the board. If it is a second move, that means turn is equal to 2, then we see if board 5 is blank, then go 5, else go 1. You understand the situation? So, if this is my turn, that means the computer's turn, and it is a second move, then either the board position 5 is blank or the opponent has already put a cross there. If the opponent has already put a cross there, then I will put my circle in the leftmost upper corner. Otherwise, if the middle position is blank, then I will put my circle, that means my symbol, in the middle position. So, this is the statement. If board 5 is blank, that means if the middle is blank, then go 5. If the middle is blank, then put your symbol in the middle, else go 1. Else the middle is already occupied. Since there was only one turn, one move before this, there cannot be any other occupied positions. So it must be that the leftmost corner, left uppermost corner must be empty. So you go and put your symbol there. This is corresponding to turn number 2. Please have a look into the next move, that is the move corresponding to turn is equal to 3. If turn is equal to 3, then what do we do? If board 9 is blank, then go 9, else go 3. That means either you put the symbol, turn is equal to 3 means odd number symbol, so cross. Either you put the cross here, or if this is already occupied, then put the cross here. Okay. Next, turn is equal to 4. Now, turn is equal to 4 means 3 moves has already been made. 2 by cross and 1 by circle. And turn is equal to 4 means it is the circle's turn to make a move. The first thing that we check is whether there is a possibility for X to win. Pursuing X. Is it possible for X to win in the next move? If it is not equal to 0, that means if it is possible for X to win the game in the next move, then you go to pursuing X and put your circle there. Because otherwise, if you make any other move, in the next move, the player, my opponent player, will make a move in this position, pursuing X position, and end the game by winning it. So my situation will not be Good. So first is check whether there is a possibility for my opponent to win. If there is a possibility, that means if pos win x is not equal to 0, then block that move. Otherwise, if it is not possible for my opponent to win in the next move, then we go to make 2. Please recall what was make 2. Make 2 means if the center square is blank, then return 5. Otherwise, you go to any blank non-corner square. So here we look for the middle position first. If the middle position is occupied, then we go for any non-corner square and make a move there, which is still open or still empty. So 4 moves are already gone. Come to the 5th move, that is turn is equal to 5. Turn is equal to 5 is very crucial because 4 moves has already been taken by the 2 players. So 2 moves taken by cross, 2 moves taken by circle, and turn is equal to 5 means it is cross's turn to make a move. So what cross will try to do? The first thing that I will see, that if it is possible for me to win, if it is possible for me to win, then I will make that move. If it is not possible for me to win, then I will see whether it is possible for my opponent to win in the next move. If I see that in the next move my opponent can win, then I will block that. If that is also not true, that means I cannot win now, my opponent also cannot win in the next, then I will make my own move so that the chance of my winning is maximized. So here is the pseudocode. If pos win x is not equal to 0, then go pos win x. If it is possible for me to win, I will win. Else, if pos win circle is not equal to 0, then go pos win circle. If it is possible for my opponent to win in the next move, block that. Else, if board 7 is blank, then go board 7, else go board position 3. That means if it is not possible for me to win, it is not possible for my opponent to win in the next phase, then I will put my symbol here or put my symbol here, 3 or 7. So I will try to occupy the corner positions, because you can see that corner positions are very crucial. Turn 6. Now already 5 turns has been taken, 5 moves has been taken by the 2 players. It is the turn of circle to make a move. Again, if it is possible for me to win, I will win. Then I will see that if it is possible for my opponent to win, then I will block that. Otherwise, I will go either to the middle or in some non-corner square and put my signature there, put my symbol there. Turn 7, if pos-win x is not equal to 0, then go pos-win x. Else, if pos-win circle is not equal to 0, then go to pos-win circle. Else, go any blank square. Because now most of the squares are already occupied. So whatever blank square is available, you go there and put your symbol there. Similarly, the same thing happens in turn last but one move. If pos-win O is equal to 0, is not equal to 0, then go pos-win O. Else if pos-win x is not equal to 0, then go pos-win x. Else go any blank square. And turn 9 is same as turn 7. You come to turn 9 means the game has ended in a draw. So this is a pseudocode for the algorithm for the second program. What do you see? You please consider this program with respect to complexity. As you can see that this is more complex. Previously in program number 1, no kind of decision making was there. Only there was table lookup procedure. Here we are no longer storing all possible moves in a table. So there is no business of a table of 3 to the power 9 number of entries. That much space is saved. Use of generalization. As you can see that this program is showing some kind of strategy. There is a strategy behind this program. So if the game is generalized to 3 dimension or say more than 3 dimension or similar kind of, then you can generalize this knowledge or this strategy for that situation also. So use of generalization is better, at least some. Clarity of knowledge embedded. If you minutely consider the individual statements or instructions, you will find that there is a purpose behind these moves. The purpose is based on certain knowledge that under this situation, if I proceed in this way, then the possibility of my winning is better. That is a knowledge. That knowledge is converted into program instructions, programming instructions, computer instructions. So clarity of knowledge is far, far better in program 2 than in program 1. And finally, extensibility of their approach. That means it is more scalable. You can extend it to a more generalized situation. You can change it, keeping the basic strategy intact. You can change it and write a similar program to solve a similar problem. So this second program shows better AI-ness than the first one. Next, we will consider the third program, but I think let us have 10 minutes break and then we shall start again.
আরে আমি তো আপনাকে একটু সেভ করে দিয়েছিলাম। হ্যাঁ। ঠিক আছে, আমি 10 মিনিট ওদেরকে দিয়েছি, টি ব্রেক দিয়েছি। আবার 3:30টার সময় শুরু করবো। মোটামুটি আমি
অফ করে দিই, অফ আছে
না, অফ নেই বোধহয়। এইটা
Huh. Hello.
Sir.
Yes, sir.
Yeah. Welcome back.
Thank you. कहाँ से आवाज आ रही है?
वहाँ पे है ना मैडम, वो दिख रहे हैं ना, पंथी दिख रहे हैं,
कहाँ है सर?
उनको तो दिख रहे हैं ना।
ये वाला। हम लोग ये है मारवाड़ी पे।
Yeah. So, we are trying to understand the basic characteristic of an AI technique. Before you go for the program number 3 to solve the problem of playing a game of tic-tac-toe, let us go back once again to the initial slides and recapitulate what we have already discussed, and then again we will continue. We said that we are going to discuss three different solutions, three different program strategies to solve a game of, to play a game of tic-tac-toe by the computer, and these three solutions will be according to increasing degree of complexity, use of generalization, clarity of knowledge embedded, and extensibility of their approach. Because these are the criteria depending on which we can judge whether a computer program or an algorithm can be reasonably considered to be a manifestation of an AI technique, artificial intelligence technique. That means a computational procedure in which some kind of intelligence is embedded. So, we promised ourselves to present 3 programs to solve the same problem, the problem of playing a game of tic-tac-toe, with increasing degree of complexity, use of generalization, clarity of knowledge embedded, and extensibility of their approach, which means with increasing degree of AI-ness. And accordingly, we consider program number 1, and we have seen that program number 1 doesn't have any kind of intelligence embedded in it, because it is nothing but a simple table lookup procedure where all the moves are stored, simply stored in the computer memory, and the technique is to convert the present board configuration into a number which will be used as an index into a very large table consisting of 3 to the power 9 elements, and using that index you bring the corresponding board position which will automatically dictate what is the next move. So this is the program with least AI-ness, least intelligence. Then we went to present ourselves with program number 2, and here we have seen that this program has a kind of strategy, okay, a kind of strategy, and these strategies are, what should I say, these strategies are realized in the form of three different procedures. The first one is make to, second one is postwin P, and the third one is go N. Go N is nothing but what the ultimately which move you are going to play, and the first two procedures are procedures to assess the current situation, and depending upon the situation, according to certain strategy, you take a decision. This means the program takes a decision, and the decision of the program or the move of the program is dynamically decided depending upon the situation of the board. That means depending upon what kind of moves the opponent has made, and under such circumstances, what is the best possible way for you to react so that your possibility of winning is maximized. So that was the program number 3. Program number 2, you see this is a pseudocode for program number 2, and now we come to program number 3, which is supposed to contain the best AI-ness or the best, the largest or the maximum amount of intelligence embedded in it. So let us first look into the general strategy of this third program. Basically, it consists of three consecutive steps or three consecutive considerations. First one is generate all board configurations that may result from the present board configuration after making the current move. So what do? We imagine that corresponding to this board position, I am going to make this move. Actually, I am not making. I am imagining that as if I have made this move. And after that, I try to assess what will be the impact of this move in the subsequent, subsequent part of the game. Whether this move will make my position better from the point of view of possibility of winning the game, or it will make the position of my opponent better from the point of view of winning the game. Whether my chance of winning is getting increased or my opponent's chance of winning is getting increased. That is what I am trying to assess. In order to do that, we generate all possible board configurations that may result from the present board configuration after making the current move. Then we determine which one is best among all the board configurations considered in step 1 above. So suppose corresponding to this move, there will be 5 different board positions, possible board positions next, and each of them will have different possibilities of winning for me as well as my opponent. So I will try to understand which one is best among them as far as my opponent is concerned, as far as me is concerned, and on the basis of that I will make the move, which is indicated by step 2. So this is the general strategy. I am not just keeping the moves stored in the computer memory. Rather, I am trying to assess the situation and dynamically decide what is the best situation for me, what is the best move for me. So that is a sign of intelligence. Now, the question is how to determine which board configuration is best among a number of alternatives. Okay? The answer is we should use a heuristic knowledge to evaluate the possibility of winning from a given board configuration. Now try to understand one thing, that I am using knowledge for taking a decision. That is a sign of intelligence, but that doesn't imply that I will be always successful. It might be possible that acting unintelligently is increasing my prospect of winning the game better than the current strategy, current knowledge that I am using to direct my action in the game. It may happen. But the point is not actually whether I am going to win or not. The point is whether I am playing the game, rather the computer is playing the game intelligently or not intelligently. If the computer is playing the game intelligently, then I can change the knowledge base and heuristic in a different way so that the computer becomes more intelligent and the chance of winning the computer in the game is increasing. So that is possible. We are not considering the actual winning of the game. We are rather considering how it is possible to make the computer more intelligent. Rather, how to make the computer act more intelligently than just like an unintelligent being which is carrying out its task mechanically. That is not what we want. So what is a heuristic function? What is a heuristic function? We will have to talk about heuristic function in more greater detail in later lectures. But for the time being, just be informed that a heuristic means a kind of rule of thumb. Rule of thumb means a kind of knowledge which promises to give you better result, but which never gives you the guarantee that it will always give you the best result, or it will always give you the result for leading to success, right? But heuristic is such that it is supposed to give you a direction. It is supposed to give you a strategy, a way to solve a problem intelligently so that you can expect to get a better result under normal circumstances. But there will be exceptions, and in exceptional situations, it will not produce good result. Take for example, in a city, and you want to reach a building which happens to be a very posh building. You understand? That means a building or a home or a kind of residential place which is very costly and very aristocratic. But you do not know the path to that home, that building. So how can you proceed? You can expect that since the building or that structure is a very posh one, so it should be located in a posh area. So with this assumption, this is a heuristic knowledge. If you search for a very big or modern and aristocratic building using this heuristic knowledge in different, say 10 cities, you may be successful in 9 out of these 10 cities. But in one city, you may find that the building which you are looking for is not actually situated in a very posh area. Though the building itself is a posh building, it is situated in a normal area. So this is a very crude example of a heuristic knowledge, right? A knowledge on the basis of which we take decisions in our everyday life, because in everyday life we have to take quick decisions, and the quick decisions which has the largest or greatest possibility, greatest probability of giving me the success, but sometimes it may fail. So heuristic function that we are going to use is like this. EP, P is a board position. It is calculated as number of rows, columns and diagonals still open for X. X means cross. Minus number of rows, columns and diagonals still open for circle. Okay. So EP is positive if there are more number of rows, columns, diagonals open for cross, and EP is negative if there are more number of rows, columns and diagonals still open for circle. Okay, and we define EP to be plus infinity if P is a win for X, X means cross, and EP is equal to minus infinity if P is a win for circle. Okay, so this is a heuristic function that I am using, and with this heuristic function I apply the decision procedure like this. First, see if it is a win. If yes, give it the highest rating. See if it is a win. If yes, give it the highest rating, of course. Otherwise, consider all moves the opponent could make next. Decide which one is the worst among them, that is, with the lowest value of EP, assuming that you are playing with cross. Assuming that the opponent will try to make your position worst, give the rating to the board position we are considering. Here, Shena? Equal Shena? Then the best move is the one with the highest rating. So in this way, this strategy is called minimax strategy. Minimax strategy, and in any AI book you will find that minimax strategy is a standard strategy to play any kind of game. And there are improvisations of minimax strategy also. So what we notice? We notice that it takes more time to make a move, because our moves are no longer prototype moves. Our moves are now decided on the basis of assessment. We have to first consider the situation, assess the situation, then consider what are the consequences, assess those consequences, and finally make a decision. However, the space requirement is drastically reduced. We do not have to keep things in storage. We do not have to remember things. We have to make a decision, informed decision on the basis of calculations, applying knowledge. The use of knowledge is much more explicit. This is the most important thing. The use of knowledge is much more explicit. The strategy is more generalized in the sense that we can easily expand it to 3 dimensions. So from the initial criteria for AI-ness of a program, complexity, use of generalizations, clarity of knowledge embedded, and extensibility of their approach, we see that the third program for playing a game of chess has the most AI-ness, in the sense that it embeds maximum amount of intelligence in problem solving. So we can conclude that the most important characteristics that distinguishes an AI system from a conventional system is its ability to handle knowledge, right? Is ability to handle knowledge. In most AI systems, we try to make use of knowledge in the program itself to arrive at a solution. So, the difference between an AI system and a non-intelligent system is, in a non-intelligent system, the knowledge is inside the designer. Knowledge is inside the person who is making the system, or the team who is making the system. And in AI, the system is made in such a way that the knowledge that was inside the designer or inside the creator is transferred to the system itself, so that when the system is run, system can exploit that knowledge to make its own decision, to make its problem solving procedure more informed, more knowledgeable, more intelligent. So that is the most important distinguishing factor for a software to be considered as a AI software. So we can summarize this lecture in this way. An AI technique is a method that exploits knowledge that should be represented in such a way that the knowledge captures generalization. It can be understood by people who must provide it. It can be easily modified to correct errors and to reflect changes in the world and in our world view. It can be used in great many situations, even if it is not totally accurate or complete. And finally, it can be used to narrow the range of possibilities that must usually be considered. So this is the summary of the AI techniques. Now, I am going to provide you this the PDF version of this PowerPoint for presentation, so that you can download it at your end and go through it. Okay. So I will give you 45 minutes to study this material once again, go through it, and I will provide you one assignment sheet as well as an MCQ question which you will try to answer, and I will come back here at 4:45 so that for 15 minutes we can discuss and that you can raise. Okay? এইটা শেয়ার করবো না, আমি যেটা করবো এটা পিডিএফ ভার্সনটা শেয়ার করবো। আরে কি হচ্ছে বাইরে কেন আসছে বাইরে যাচ্ছে কেন আচ্ছা এটা কি করবে ডাবল ক্লিক এবার এটাকে আমি ইয়ে করবো তাই তো হুম আচ্ছা এইবারে মানে আমি যদি আরেকটা ফাইল এরকম ইয়ে করতে চাই আপলোড করতে চাই এগুলো কি এখন ওদের কাছে অ্যাভেলেবেল হবে
হ্যাঁ অ্যালাউ করে দিয়েছেন ওরা তো ডাউনলোড করে নিয়েছে
না কিন্তু এবার যদি আমি আবার একটা নতুন ফাইল খুলি এটা থাকবে না এটা কতক্ষণ আমি রাখবো
ডাউনলোড কমপ্লিট হয়েছে কিনা একটু লিখে দিন হ্যাঁ
হুম
না করে ওরা আবার বললে পারে
তো এটার মধ্যে
এর মধ্যে করতে হলে তার এইখান থেকে আপলোড করতে হবে।
ও
এই মাউসটা করে আপলোড করলে ওখানে দেখায়।
ঠিক আছে, দেখা যাক।
নরমালি
দেখা যায় কিন্তু একটু Okay, is it tasteful? ঠিক। হুম 10টা। Yeah. দশটা।
পরে দিচ্ছি,
হুম
পরে দিই ওখানে যাই, বাইরে ক্লিক কর, বাইরে ক্লিক কর।
Mm-hmm. আবার ওটা বাড়িয়ে চেয়েছি। ঠিক আছে? Hello. So I see that some of you have already solved the MCQ test. So before we call it a day, let me provide you the answers so that you can check, verify. Yeah. So the first question is, the phrase artificial intelligence was coined by Albert Einstein, von Neumann, John McCarthy, William Shockley. So I hope you have gone through the two study materials, the PDF version of the two PowerPoints that I have presented today. So the answer is available in those materials. So let me tell you the answer. It was John McCarthy who coined the phrase artificial intelligence. So the correct alternative is C. So this is the correct alternative. Next is, which of the following is not true for AI? Not true for AI. AI tries to simulate intelligence on computers. This is true. AI exploits knowledge to solve computational problems. This is also true. So the correct answer for this, correct alternative for this question number 2 will be neither A nor B. That means alternative D. Is it okay? আচ্ছা একটু দেখা যায় যেন কি হবে অলরেডি না চ্যাট না যে কোনো একটার উপর রাইট ক্লিক আছে এরা अच्छा हाँ अच्छा तो AI is it. Okay. Now question number 3. Chat. Question number 3 is, which of the following is a mundane task? Speaking, walking, seeing, all of the above. So কোথায় কি করে জিজ্ঞাসা ঠিক আছে এটা তো বলে দিয়েছি Q3 So the correct answer for Q3 is D. Now come the next one. Common sense reasoning can be categorized as a mundane task, expert task, formal task, none of the above. Can any of you give me the answer? Yeah, correct. Mundane task. Okay. Mundane task, correct. Correct. So the correct answer for Q4 is A. Which of the following, question number 5, which of the following can be thought of as a formal task? Game of chess, classical music, painting, none of the above. Anyone? 5A, correct. Game of chess. Very good. Congratulations. Which of the following is not an expert task? Architectural design, medical diagnosis, computer maintenance, none of the above. Correct, none of the above. Which of the following is an application area of AI? Natural language processing, robotics, image processing, all of the above. All of the above, correct. According to physical symbol system hypothesis, for general intelligent action, a physical symbol system happens to be a necessary condition, sufficient condition, both A and B, neither A or not B. C, correct. 9. Which of the following is a test for AI in a computer? Turing test. B, correct. One important characteristic of an AI technique is it has very high algorithmic complexity. It tries to exploit knowledge in its methodology. It mimics the behavior of wise people, none of the above. 10. B, correct. So thank you very much. And I expect that the assignments that has been given to you, you will try to solve them. And tomorrow in the morning, when we start again at 10:30, at about 10:30. So please be here by 10 o'clock so that we can make connections to all of you. And we can start the session at 10:30 sharp. But if you come at 10:30, then it takes almost half an hour to make the connections and establish the communication channel. So please be here at about 10 o'clock. We will start as soon as all the all the institutes has made connection. Thank you very much. See you tomorrow. ঠিক আছে।